We are recording. All right, so what I thought I'd do is a little bit of a State of the Union kind of message here about CORD. Where are we? What challenges do we still have? I'm going to include in the middle of this a little draft version of a talk that I'm going to give at ONS, which is actually inspired by the discussion we've been having anyway, so it kind of addresses some of the architectural questions. But I'll tell you when the middle part should be pretty obvious because the slides will get full of pictures instead of words. Okay, so where I thought I would start is just with a quick overview of what we're trying to accomplish in Dangerous Edition. And those of you that have been following know that there's a lot of stuff on the roadmap, and the roadmap's pointed to design documents, and unless you've really been participating in the discussions, probably not very good. Right. So a lot of what's going on in Dangerous Edition, the third release of CORD in weeks, is basically stop and take a breath. We've been moving very, very fast. We kind of rushed out creamy vegetables so that we could launch CORD, and we cleaned up as much as we could for the second release. And people are starting to make use of doing demos, and that's all good. But there are clearly some issues, and those issues and trying to figure out how to address them in the last several weeks. And I've this is a little bit lumpy, and so we could drill down on any one of these, but in a sort of a high level, our set of things that just weren't working as well as they could do. And so we're going to try to make those better. So the first one, I'm just going to characterize as XOS is hard to use. It is moving very fast. It has...
Is it just me, or does this sound really weird? I'm getting you fading in and out, Larry.
Oh, all right.
No, that's not it.
We're actually using that mic. Maybe we should dial
just dial in. Maybe that's easier.
And stop using that mic.
Larry was really strong at the beginning of the meeting, but he's definitely gotten a bit brittle.
Okay.
Oh, well, Brian, do you think it's a networking issue or an audio mic?
No, it's an audio issue.
Let's dial in with the Polycom.
Okay, give me the numbers.
Or network.
Yeah, that's right. That should be good. I don't have to.
Just say use phone call, and it will give you the number.
Are they dialing back in?
I believe they are, yeah.
Thanks.
Hello.
Hey, Guru, we can hear you.
Okay, now Larry is the one you need to hear, right?
Can you hear me okay now?
Yeah, you sound much better.
Right. Okay,
Thanks.
so as I was saying, these are some of the high-level takeaways of the kinds of things we're paying attention to. So the first one is that XOS is difficult to use. It's convoluted. There's a lot of cruft around it. You have to, if you're responsible for onboarding the service, you've got to write this py file, and so on and so forth. And especially if you go looking through the code for some examples, you might become confused because there are lots of examples, some of them done recently using the latest best practices, some done months ago using a previous best practice, and so it's kind of hard to know how to work with that. So that's the first general category of things we were paying attention to. The second is that anyone that's built CORD knows that the process to build out of either a full pod or an emulated pod is a slow process. It's often brittle, will break on you. What can we do about that? The third one is somewhat related, which is that there's just insufficient diagnostics, both from a development point of view if you're troubleshooting, but also from a project management point of view if you're trying to stand back and understand what is and is not working well. There was just too little information to go on. And the third one is just people out there trying. So this is our version of the operational aspects of CORD. Is if you're trying to operate CORD, and for us that means you're trying to operate it as a demo. Just simple things like restarting proved to be challenging, and you really had to know exactly the right script to follow, and even then sometimes things didn't work out so well. So these are obviously all problems to be addressed to make the system better. So there's been a lot of discussion. Many of you have been participating over the last several weeks, and if you kind of go to both the roadmap and Jira and look at what the major epics are, you'll see a couple of refactor epics, and that was sort of our attempt to try to understand what was not working and how we could address it. So the first major bit of work is what we call Refactor XOS. And I'm going to go through a lot more detail in a few minutes, but just as a kind of a high-level take on that, that really had to do with modularizing XOS better. And in this context, that meant breaking it into a set of microservices. And trying to apply best practices in building out a microservice architecture, just around the XOS piece itself, right? All of CORD is made for microservices as well, but just in terms of that management piece.
Can you explain what you mean by microservices?
Yep, I will. So read this as more modular. And the second thing was there's a lot of Python that you have to look at and emulate if you wanted to write your own service. And so we're trying, it was always model-based, but the models were expressed in Python. And so we've tried to move to a much more declarative model of the way that you onboard a service and say what your service does, and then automatically generate various APIs from those models. So more modular and more model-based were the two things that we were trying to bring to that first problem.
So the capability of one of the great things about learning real languages is second order records, first order language. It's really expressive. You can write a loop rather than having a
right. All right. So this is a lot of that capability. So there is still an imperative part of what's going on, and I will try to tease that out in a little bit. But in fact, if you were trying to look for the root cause, in my view, of why this problem suddenly came to the surface, and why this is trying to address the root cause, it would be the following. As a lot of you know, XOS was originally implemented as a Django application. And Django, it basically, you express your models in Python, and then you expressed how you want your GUIs in Python, and so on and so forth. It was a great prototyping language. And we learned an awful lot about what the CORD models ought to be, because we were able to rapidly prototype. We were able to support demos doing this service and that service rapidly because we were using a prototyping language. But refactor was actually the right word here. This is XOS reaching the point in its life cycle that said, we think we now kind of understand what we're doing. Of course, we will learn a year from now we really didn't, but we think we kind of understand what we're doing now, and let's try to just codify that. And there will still, of course, be the ability to continue to innovate going forward, but at least we'll have checkpointed some best practice in these set of models today. And I'm going to spend actually quite a bit more time on that. In terms of the build process being brittle and slow, this turned into the very large epic, which we're just calling Refactor the build process. And just to try to capture the principle that we're trying to stick to here, is we're trying to break the build process into some well-defined stages. Where first you configure what you wanted out of CORD, you then fetched all the pieces you need, you then built containers, and then you deployed the containers. Now, where we started, just to give you a sense of why this has proven challenging, is we were first building our CORD. You build an R CORD, then if you wanted an M CORD, you had to back out of R CORD, and then you had to start over again doing pieces of it, and there were containers being built on the head node, and we're trying to move all the build back to the development node. So it's a more systematic and rigorous staging of when things happen. If I were being critical of where we went wrong earlier, it would simply be that to get things going, we divided the world up and we did a divide and conquer. Not to put too fine a point on it, David Bainbridge took the metal as a service and he ran with it. And then Andy took, let's get OpenStack running once we have metal up. And then Scott said, once we have OpenStack and XOS up, let's onboard the services. And so we kind of went down a layered, I've never been disturbed.
Hey, Larry, if there's questions being asked, this is Donna. I'm not able to hear the questions, but I'm able to hear you really well.
Oh, okay. I'll try to remember to state the questions.
Thank you.
So, in any case, my analysis of what happened here is, you know, out of sheer pressure to get the very first versions up, there was sort of a horizontal division of the problem. And it's still true that you have to bring the metal up before you can bring the OS up, and before you can bring the OS up, then you bring the services up. So it really turns out this is a two-dimensional problem, and it's not clear that you entirely go left to right and then bottom to top, or bottom to top, left to right. It's actually you're somewhat diagonally walking through this range of possibilities. But I think we are now at a point, and I'm not going to spend a huge amount of time on this one because I think there's pretty much consensus as to what we should be doing. It's just a matter of executing on that. But I'm going to add a sub-point here, which is actually turns out to be one of the really hard problems that we're facing. And this theme will come up over and over again, which is there are different stakeholders involved here. And I think the other thing that happened to us is that some people were optimizing for one stakeholder and some people were optimizing for another stakeholder. One of our stakeholders is, this is an operational system, supposedly, when you're done. So if it's operational and I've got it deployed in the field, I behave one way. No, this is a development environment. I'm a service builder. I want to develop my service, and I need to rapidly prototype my service. And so those two modes of use put tension on the build process. And I think, like I said, I think we're at a point that we are reasonably well aligned in what everyone's doing, but it took us a while to figure that out. And in any case, once we have this foundation, I think it'll be possible to streamline the environment for different purposes. Streamline it for QA, streamline it for operations, streamline it for development. And right now, sort of just work gets done because people have understood that I'll bring it up one way, and then I'll get my own little tight development loop. But that's kind of hard to replicate for other new people that come to the table. So hopefully that will clear up. The third thing was just sort of globally there was insufficient diagnostics, and so there's now support added for ELK stack and data being collected. You still have to instrument various pieces of the system, but that's happening. And this we believe is going to help quite a bit with diagnostics from a development point of view. But I think it gives us something else, which is just more long-term data so we can track progress. There's a lot of anecdotal information that says I deployed 6 cords in the boxes and 5 of them failed. And I got someone else that said I deployed 6 and they all worked. And so we're just lacking data, and we're starting to now collect that data. So I think we will be able to document quantitatively incremental improvements to the system over time. Yeah.
How much of some of the problems we have today have to do with OpenStack conflict?
Well, so we could do a deeper dive on exactly what the
questions.
All right, so the question is how much of it's due to OpenStack and this or that. So again, it's anecdotal, and I'm hoping that we can come up with the data to support this. But a huge part of what does fail when it fails is that we optimized for the stakeholder that wanted to do continuous integration across an entire build. And there's a very good argument as to why you do that. You make a change, and for your part, you know your change worked within your scope, but we still want to do the end-to-end build. That's what takes time, and B, puts you at risk of failure at any stage along the way, including installing OpenStack. So that actually is one of the heavier things that happen. And again, I'm going to come back at the end. I'm going to talk about priorities going forward. We can certainly touch on this a little bit more there. The final thing is just operationally, it's hard to use. And this has sort of been reduced to a requirement that we do a better job discovering our environment. And what I mean by that is, as the system boots up, you discover what servers are available, you discover what the fabric looks like. Well, yes, that was kind of there because of metal as a service, but we actually got bogged down in understanding what the fabric looked like. And then if you start to introduce the environment changes over time because there's failures and restarts, operation, as an operationally supportable system, we still have a ways to go. Now, I don't have any, in terms of dangerous addition, we're just barely making a dent on this one. This one is a much longer term difficult problem. There are some things that we plan to do going down the road that will, I think, significantly improve it. And oh, by the way, once we get this better, then this will be an easier thing, at least when people are doing demos, it hopefully will be an easier to understand environment so that you can pick up in the middle of a demo and restart from here forward. But that all hinges upon getting this done. And quite frankly, just in terms of where we'll get for dangerous addition on the configure, fetch, build, deploy, there's been quite a bit of refactoring in the code base already. The thing that's going to be the most challenging is actually OpenStack. And so that little sub piece isn't probably going to be completed because we can't fully containerize it until we take a bigger step than we have time to take for dangerous addition. All right, so by the way, I didn't put QA on here. QA is something that is getting attention in dangerous addition. Incremental improvements are being made. But I don't have anything too strategic to say about it. It's something that we know needs attention and work, and it kind of has its threads throughout a lot of this, in fact. So when I get to the priorities at the end, I will call QA out a little bit stronger than I did here. If there is work being done, I didn't mean to cite it in that sense, but it wasn't like we could say, this is a change of course that we need to make. I think that we just need to do more. So I debated which of these two slides to start with, and I decided to start with dangerous addition, but this is sort of an equally important thing to have in your mind. And that we face a lot of challenges, and actually it's what makes the project an interesting one in my mind. Like I mentioned, we're balancing the requirements of a lot of different stakeholders. And I'm going to call a few out because they turned out to be tricky. One of them is network operators. That is to say, one day you're running a CORD pod in your central office, you want it to behave in a particular way, and some of the requirements on how you build the system and so on derive from that. And then you have service developers who maybe need a tighter development environment to work in. And so just literally in terms of the build process, and the kinds of, why does it take 3 hours to bring that CORD in a box? Because we were trying to build it from source. And, these kinds of things come into play. There's a second set of stakeholders that are sort of at odds with each other, which are service developers and platform developers. And and I call that tension out here as a very important technical tension. As a service developer, you have one objective and one objective only, to get your service implemented and your demo ready for MWC. You could not care less whether what you do is of value to the general platform. And I'm not criticizing that, that's just the way it is. You got to get your work done. And the platform helps you up to a point, and then it gets in your way and you start working around it. The other side of the equation is that the platform developers are doing their best to create a general purpose platform. So the next service developer that comes along has more capability available to them and their job is easier. So we're learning from each other and it's a give and take, but at any moment in time, this is a tension that we just have to figure out how to deal with. And if I were to go back and actually look at the code, I would say that there's a whole lot of demoism that just got done out of the sake of expediency that are still in the code. We've got to figure out a way to find the time to go back and clean those up so we don't need those major refactorings. Maybe we still do those every now and then, but that we can incrementally keep things clean would be a good situation to be in. And this last one is, not so I'm confusing myself as to which one of these last two, they're very similar, but just in terms of the time, use case teams, platform teams. Actually, I don't remember now why I threw those two out separate. Oh, well, I'm sorry. I'm just distinguishing between working on a single service versus the platform versus you're working on like a whole MCORD solution versus the platform. So as teams, you have different objectives, and we have to find a way to balance those objectives. We all understand there's a balance on our time. So the next demo takes time away from the next release or vice versa. And we just have to figure out the right way to prioritize those. And likewise, the next field trial takes away from the next release. And so, you know, every sprint, we're having to balance, do I finish the feature that these guys are waiting so desperately on, or do I help out this demo or this field trial so that they make some customer happy? Everything I'm describing here is the same thing that you face in a business setting, except we're drawing on an open source community, so that makes it doubly challenging. But if I reduce it down to the technical choices that are at the real crux of what makes this hard/interesting, it is this notion of trying to build out the capabilities of the platform by understanding what the service requirements are. Again, the tension is the services need to get their work done, even if the platform doesn't fully support them. So we have, again, that's the tension that this is, in my mind, this is classic operating systems, which is why I find this such a fascinating project. It's always about the platform versus the users and trying to find the right place to draw those lines. There's a specific problem, though, that we face that actually traces its roots back to service developers versus network operators. And this is another classic system design trade-off between isolation. I get to work on my service, and I don't have to worry about anybody else's service, versus I have to operate this thing across 20 services I got bound in, and I need some global visibility across those. So isolation with visibility. And that's, again, a classic system design trade-off that we have to find the right balance for. And we have that in spades in CORD. So these are just sort of keep in mind. They influence how priorities fall out, how different people have different perspectives. So what to one person might look to be the obvious right solution, to another person is doesn't make any sense because I'm trying to optimize something else. Okay, so that's kind of the start. Maybe I can stop for a minute before I move on. What I'm going to do is kind of dive down into the architecture a little bit. And you've seen me do 100 presentations in the CORD architecture. I'm going to do a different one. So I'm giving your feedback on it because it's supposed to be general purpose, not just for CORD experts. So hopefully this may disappoint you if you were looking for too much technical depth, but hopefully the ideas will be important. So, but before I go on, are there any other?
Okay, so I have a generic question here. Concept of head node that we have right now, we have only one head node for CORD 4, and most of the control plane services are running there.
Yeah.
So that's not a highly available.
No, it's not. That needs to be done, but it has not made it to the top of the priority list. I don't think we've done anything. It's just that we've not taken the step to do it.
But do we really need a node to be designated as a head node?
No. I don't think the head node compute node distinction is critically important as long as we have a set of services, some of which are part of the management plane, some of which are part of the service plane, and the management plane needs to be highly available too. Actually,
so we can take a smaller subset of the compute node and orchestrate the control plane. Yes.
Yeah, we could. We could statically partition the nodes into, and in fact, that's where we started, into head and compute. But I think what we would really like to get is that control that what you would call the head node can be distributed across the compute nodes, and that distinction.
And can those that are not speaking please mute?
Hi, Larry. This is Mali. I have a general question since your topic is beyond microservices. Microsoft and Amazon are right now moving from microservices or have moved out of microservices to Lambda function based, which is really another computing paradigm that also works for IoT. Since we don't want to repeat an orchestration, a separate orchestration for IoT, could we also move this architecture to a Lambda function-based type of environment rather than just microservices? I'll put myself on mute.
Yeah. So the industry continues to cycle, and we're just we're quickly on our way past microservices off.
Yes, someone's.
Did everyone check their mute
We can mute them all.
This guy.
Okay,
Well, just
don't
mute all
come
of
up to me. Okay, I know. Oh, I know this.
mute whoever needs to mute all.
Them all.
Okay, for those of you listening, yes, we've now muted everybody. But if you have a question, if you were to type it in the chat window, at least to alert us that you want us to turn you back on.
They should be able to unmute themselves.
Or I guess maybe you can unmute yourself. Okay. So on these, it's not surprising that running functions in servers is now the next thing. That isn't shocking at all. And that is a capability that one ought to be able to do inside of what we're doing. So you nest these things. The same way you can nest containers inside of VMs, you can nest Lambda functions inside of containers. And so I don't think we're prohibiting any of that. In fact, if you wanted to build a really powerful VNF onboarding subsystem that we could try out in CORD, it might be one that onboarded Lambda functions. And we could run that as a microservice or as a full-bore service. So it's certainly not prohibiting that. It's just that we're not necessarily using that as our first principle to start with. And actually, that reminds me, read the requirements page that's on the CORD wiki. If you've never read it before, please read it. And one of the things that it calls out as a requirement is that we can support a range of functions. So it's not, I'm going to talk about microservices and beyond, but it should not be the case that we can only run container-based services. We will not met the requirements if we do that, because there will be legacy VNFs that will need to run in full VMs. Now, we can spend time trying to optimize the container case because we think it's critically important, but we need to, at least architecturally, if not in the reference implementation, include the ability to bring up all VMs. And moving forward, we should be able to support Lambda functions, but that's going to take work. It's not going to come for free.
I think we should just call it as workload, and workload can be VM or container.
Right. So that dimension is explicitly called out, though, in the requirements page. Okay, so now I'm doing a little bit of the talk beyond microservices, but again, it was inspired by the discussion that we have been having in the CORD platform team over the last several weeks. And in that discussion, there's been a very strong identification of microservices as a good organizing principle for building not just random services, but the management system itself, the CORD controller and XOS in particular. And so I wanted to explore the relationship between microservices and what we're trying to do in CORD so that we kind of have that, understand that architecturally. So for a couple slides, a little primer on microservices. You build a cloud application by leveraging a collection of reusable container images. And you can kind of think of there being a library of these images out there. And don't take this literally. This is very illustrative. But I can build an app with a GUI, a REST API, fronted to a database that maybe has an event bus. And yes, it's going from left to right. It would be an arbitrary graph. So again, don't take it literally. But the point is, you build apps from a set of container images, and there's now a growing collection of container images. Think of them as you're in the cloud space, it's your library. And I have a really rich library available. And I have a tool, like Docker, that makes it easy to then deploy those. So not only do I have the images, I have a deployment technology. Great start. And then I can scale each service independently. So however, this is my picture. I start with one container and I grow the set of containers. Each service scales independently. And in fact, I don't talk about the container in the next service. I talk about the service as a whole. So I can load balance across containers in a service. And what I'm just now describing is some of the basic fundamentals of a container management system like Kubernetes.
Larry, can I ask you something? So you mentioned, you were talking about services and you jump to applications. And applications are basically a set of services chained together.
So I'm in a cloud application. This is the way that a lot of people build cloud applications. So what's a cloud application? Well, first of all, you could go to Yelp. All right, that's probably built from a set of microservices, just from what I've heard people talk about. Netflix is a set of microservices, and so on like that. So it's to build a cloud app. An app is a bigger thing, and it's built from building blocks, microservices. And not only, by the way, do these tools load balance across containers in the service, but they also tend to do a pretty good job of load balancing containers across the set of services. They do scheduling, they do service placements. So this is all wonderful stuff.
I'm confused by this idea of microservices. You know, that seems like maybe a sensible idea. Small little process, a little bit of data in a, you know, in a like a secret namespace. That makes sense to me. It's like how I built Mininet, right?
Right.
But then you mentioned like Docker and Docker images. Oh, isn't it great that we have all these images? No, it's terrible because for the most part, each of these, you know, quote, these images are, these are not microservices, they're monster services. Because each one of them ships with an entire OS image, which it requires to run. And not only that, but like we have this great thing, shared libraries that can save both RAM and disk space.
Okay, so all right, so now for everyone listening, the question is,
why monster services?
Why monster services? I'm not going to have that. It's a valid one that, in some sense, we have just reinvented the wheel. But
the square wheel is the problem.
So I'm not. All right, so you and I can have that discussion offline. You're right that there's a whole lot of reinvention going on here, but I think the thing that's most compelling about this is the independent scaling aspect of it. That's what people eventually get to. Before everything up to that point it was just modularity by another name. But that I can scale these is a valuable thing.
Yeah, but the way they're deployed is the opposite of scaling, because things are much larger than what you're doing.
All right, fine, yeah.
So yeah, I just don't understand it. Anyway, like I said, it doesn't seem to be micro, which is something different.
I've been very slow to embrace the term microservices because I didn't like to micro myself, but sometimes you just have to go with what everyone else is calling them. And I learned that, I come to that stubbornly myself.
Like, I guess it's not so much the terminology, it's just that it's bad. It seems like an inefficient and inefficient system.
But there's nothing that prevents it from being like.
It could be done better. It could be done better.
Right, so
it
could be done much better, and so it's presumably people will continue to improve it. The last piece of the puzzle is that this quite often is argued as dovetailing very nicely with the DevOps model of management. And so I'm going to just pictorially think of there being some kind of playbook that is the control plane for this service. I configure it, I control it. And I'm just going to represent that. You can read Ansible playbook if you want. That's what I intended. All right. So there's a rich tool set. And, you know, you talk to two people about Swarm and Kubernetes, and then we each have the opposite view. I don't want to have that discussion. This is a paradigm that people are using to build scalable services. The isolation properties that I can build my service and scale it independently of you is very powerful. I would take it one step further and say that once I've done that, you shouldn't have to repeat that process over again inside of your application because I'm already running a NoSQL database. You should use my NoSQL database. And that characterization is, in my mind, the difference between microservices and everything as a service. It is something that I stand up once on behalf of many use cases, but we'll get to that in a second. This is microservices, and remember the title of this little piece is Beyond Microservices. And this gets me to a set of assumptions. The assumptions are that I'm doing this to build a single application for some definition of application, but it's my app. I'm just modularizing it in a scalable, in a way that allows me to scale the individual pieces. And that implies there's a single trust domain and a fixed set of services. If I'm building Yelp and I need an event bus, then I need an event bus. If I don't need, probably need a database, but whatever I didn't need, I don't suddenly need it tomorrow. This is the app. I figured out what the modules are and I build it. So it's a fixed set of subservices or microservices. It also assumes a fixed infrastructure. The virtualization technology is quite often fixed, and the network functionality is quite often fixed. So I'm going to just spin a slide on each one of those. So on the notion of a single app, what this means is that when I build whatever this service is, I assume that I trust the client of that service. And if there's only one, because it was mine, then things are perfectly fine. It's assumed you're in a single trust domain. But if I ever wanted to take this service, and I forget which one is what, the NoSQL database, and I want to suddenly support 2 clients or 3 clients or in general be multi-tenant, then I have to trust all those tenants. Well, if they were all part of my service, then I trusted it implicitly. But if I'm building some general purpose platform, then I don't necessarily trust them. And in terms of the fixed set of services, what tends to happen is that I'm in cahoots with myself here, and this service always depends just on this service, and so you just start to get hardwired dependencies. And I'm not saying anything we're doing in CORD magically makes hardwired dependencies go away, but we're trying to structure in a way that they get called out explicitly. Moving from implicit dependencies to explicit dependencies. So that's the single app limitation of microservices. And I'm sorry, it's an assumption. It's been perfectly fine for certain settings. The other assumption is that the infrastructure is fixed. So for example, I get one and only one virtualization technology. I get Docker containers. I don't suddenly get namespaces. I don't suddenly get Lambdas. I don't suddenly get KVM. I get one form of virtualization technology. That's one we all recognize, and it'll take some engineering. We can work around that one. Network functionalities are really challenging. And it basically says, my container management system has an abstraction for how service A talks to service B. Take it or leave it. That may or may not be the right thing for your particular application. But more importantly than that, we actually live in a world where some of the services don't just run in containers and process data and store it and so on and compute. It actually controls switching elements. They're control apps. And there's no allowance for control apps being services in these other systems, not at least as a first-class object. There's one caveat I need to say. You always are free to program around this, right? It's not like you use Kubernetes and someone ties your arm behind your back and you can no longer code. You always have the ability to work around these things. But I'm calling out as these assumptions are ones that we can face head on, and that's what we're trying to do. So,
question: Are you saying that the microservices from different, that most I guess orchestration systems that for microservices don't allow you to pick and choose the virtualization technology per service? It seems like some service might be available at VM, and other might be available at
not typically.
And
not
then
typically.
also that, and typically, and then also that the networking part is pretty much networking part, and in particular deploying pieces of service in the network is pretty much under their radar or not.
Right.
Really,
And the same thing. And the same is true for OpenStack as well. So it's not just container management systems. You could make the same argument there.
Yeah. I mean,
all right.
It's their major blind spot, and it's not our blind spot.
That's exactly right. So I think that's one of the key things. So I just went from microservices to beyond microservices, in case you didn't catch that. And so what we're going to basically do is we're going to build another service. It's going to be cross-cutting. And let's give it a name. Let's call it operations as a service. I could have called it orchestration as a service. I could have called it management as a service. You could come up with different names there. I'm going to call it operations as kind of a neutral term. Because if I call it orchestration, then that will have some implications that may be not quite right. And this is going to define for us a service control plane distinct from the service data plane. So you will all recognize an SDN-like strategy going on here. We're going to take what used to be owned by the microservice, and we're going to break it into the data plane and the control plane. And that's intentional. The parallel to SDN is pretty pronounced. Metaphors always break down at some point, but it's a pretty good metaphor. And having done that, from the operations service, you will configure an individual microservice. You will acquire tenancy in a microservice, and that will be mediated by the operations as a service. Once you've acquired tenancy, you can use it in the data plane. You don't have to go back to the control plane every time you want to do a get or a put or a read or write or a send or receive. You do that directly in the service data plane, and I will control on behalf of one of these users, one of these tenants, that instance that I got in that out of that service. And then on the side, I will also be able to monitor. And I don't put monitoring is kind of on the side because it is implemented as yet another service. And just as an aside, before I forget to say it, monitoring as a service is itself a fairly large service built in a set of microservices. So this principle can be applied inside of your service as well.
And who monitors that?
Hopefully it will be self-monitoring. Well, so ultimately there is a responsibility for monitoring instances that make up a monitoring service that someone's going to have to help us with. And it might be Kubernetes, it might be XOS, or some combination thereof. All right, so if I go back to these assumptions, this service control plane now is not a single app, but it's a multi-tenant platform. It mediates trust, and it gives you a configurable set of services as opposed to a fixed set of services. And it has a programmable infrastructure. That is, it will support multiple virtualization technologies, assuming we go to the work of importing them, but it doesn't lock you into one. And perhaps most importantly, you get SDN control apps as services.
So something else I guess I don't understand with the multi-tenant thing is the way I've seen this sort of approach work is that when you have multiple tenants, you just create another instance of the quote of the service, because the services themselves aren't necessarily multi-tenant, and even if they were, they probably don't give you isolation that you trust. And so isn't this just sort of, building on it rather than changing its infrastructure, or are you really thinking they're going to be trusted multi-tenant?
Being multi-tenant can have different implementations and different levels of isolation. So I may isolate the tenants by putting them all in their own containers. I may isolate them in a namespace. So there's different isolation, and depending on the service, I'll be more or less happy with it. I might be happy with namespace isolation with a NoSQL database, not worried about performance isolation. And that actually you would build a CDN in the same way.
I guess are you thinking that is the model changing where now these services support multiple tenants, whereas previously they didn't?
Oh.
And is there any reason to believe that now they're more trustworthy and it's okay to do that?
It is. Some services are natively multi-tenant, in which case we've just interjected ourselves for the opportunity to enforce policy. Some services are not. We have an example of that actually, where we have enforced isolation by forcing every tenant to go through a container to get to a common backend service. So there may be more or less work to do. And how much granularity there is to tenancy is actually a very open question that we need to address, and I'll have an example of that in a minute. So just to put this into a picture that is more familiar to you, if I add in the compute and switching resources, and I populate some of these microservices, and now I'm suddenly making a transition that these are not necessarily implemented as microservices. They may be full-board services, and that's okay. It still fits the model. I get a network as a service, ONOS. I get a container as a service, or if you prefer compute as a service, it could still be OpenStack. I get some services that are control apps, and I get some services that are some random VNFs that run in containers or VMs. And I can get more than one of a bunch of those. So there's an interesting question. I can certainly get more than one compute as a service. Can I have more than one network as a service? We haven't done that yet. It's kind of one or none at the moment. If we get to network hypervisor, then maybe you can run multiple. And this thing has a name. It's the CORD controller. You package it all together, you get a pod. And then the question is, what value does this purple box at the top give you? It gives you the declarative state, which is to say, if it's a sufficient state to start, restart anything inside of here. I don't need any outside help. It mediates trust. You have to acquire tenancy. It enforces policy and invariants. Part of the invariants are actually hardwired into the data model. Some of the invariants, they're going to be little chunks of code. We still have to cope with that possibility. And it activates the data path, or orchestrates the data path based upon its state. And this is the piece that XOS is trying to implement. So pulling away the covers on what's inside of that box, and this is now dangerous addition going forward. This is not the way it used to be. It is itself a bunch of containers that can independently scale. There's an XOS core. It has a database for persistent store, and when the core changes, events are published to an event bus. There's a set of front ends. Let me put the annotations on here. This collectively is the data model. There's a set of front end views, and there's a set of back end synchronizers. And I just pulled the little boxes that were the DevOps playbooks and made them be part of these containers down here. That would be a very typical implementation there. Now, the refactoring work is part one, going towards something like this. And the guys that know exactly the names of these containers, this is slightly generic version of it. There's a little bit more, there's actually some extensions to the GUI that are in their own containers. We haven't yet done Yang. Tosca on the next release will still technically be buried in here. We won't have the time to pull it out. This is based upon Chameleon as a translator. In any case, there's a little bit of detail behind that, but it's essentially the first big part of it. The second big part of it is that we went inside of here and we're trying to codify the data model in a way that's independent of the underlying Django.
So I have a question here. How does XOS decide which compute node to select for a particular container? Whenever XOS has to instantiate any container.
From an API, who picks what server a container goes on? From an API point of view, that is a configurable parameter that's passed into it. And if you choose not to make a decision, there's currently a trivial scheduling algorithm. Another answer might be that the underlying compute as a service has a better scheduling algorithm. So maybe once this is Kubernetes is supported, Kubernetes would make that choice for you, perhaps within some constraint that it has to be from one of these three servers. But right now, what typically happens is you're passing in that selection as a parameter. The placement, the scheduling algorithm.
Is the protobuf that is it part of that XOS core?
Yeah. So everything that I just described here, these interfaces are all going to be protobuf or PC based until I translate it to something else.
One more question. In terms of the dynamics of the services and all of that, I mean, that control that you were mentioning on the core control, how would we, what can the way react dynamic service chain? Well,
so dynamic. So I'm going to do service chaining in a little bit more detail because I think there's a general misconception about it. But you extend the core. So let me go. You're actually taking on my bullet here. So there is a core set of models, and this is kind of an unfortunate double use of core. Maybe the previous one should have just been XOS container, because there's a core set of models, and then I extended by onboarding per service models. There is now an internal representation of that model that's independent of back-end implementation, which is still Django until we switch it out. That representation, we decided to go with protobufs. It could have been something else, but that actually also is our external interface, so we just as well. It is syntactically consistent with protobufs. Soften would get upset with me for trying to sweep too much under the covers here because semantically we have had to extend protobufs. Consistent with the syntax, but with new meaning. There's both policies and state that's part of this model, and there's both declarative state and runtime state. And all I mean by runtime state is every time you instantiate a container, I'll get back an ID or something. That's runtime state. That's been saved as part of this, it's temporary state because it could change. And then we generate interfaces from the data model. That's the representation again. And there's an onboarding operation by which I extend the model where I give you a new model, a synchronizer container, and a GUI extension. Sorry, was there another question?
Yeah, whenever I look at data models, I will try to figure out, like, well, what are the semantics and how are they described? And it looks like the semantics in this, the only thing I see is policies, which I think must mean policies, although it could be also policies that they regulate and enforce laws.
Did I misspell policies and police somewhere here?
Yeah, for sublet on the data model.
Oh, yeah, that's policy.
State is like data state, not like the nation state or something.
Yes.
State police.
States, all right, so there it is. Yeah, so, all right, yeah, you got me. This is actually all a grand plan.
Is that what the semantics are, or the policies? In which case, I'm interested in how those policies are specified and what they mean.
So we're trying to represent as much of the state as when we call it statically timed, static check invariants. They're actually represented in the models relationships. Yeah. But we don't believe that's sufficient. And so there are these little chunks of code that are hopefully in a very regular way, annotations on the data model, but they get executed. And Over time, this is something that hopefully we will learn from, and we'll be able to represent them as invariants, but we sort of need that escape hatch, I think, going forward. The synchronizers, again, you've heard a lot of this, but it's just slightly repackaged. It's built from a base image that includes the synchronizer framework. What is that framework? It's this bunch of stuff. So you're not starting from scratch. And it includes a sync step that's invoked whenever the model changes. That can be driven by a periodic polling of the model or that event bus. And it quite often includes an Ansible template that then gets filled up by the sync step based upon the state in the data model. You get to write arbitrary code here. We're trying to produce a best practice reference implementation as to what these typically look like, but there are services that have more complicated behavior. So I don't think we have tried to reduce this to simply a filling out of the template and have not succeeded. I think there will probably, as we move forward, be a set of synchronizers for which it is possible to give just a template, and then all you have to run is the generic base framework. That would be a very good state to get in, because then many of your synchronizers would be the same except for the template, but I don't think we can claim that universally, so it's not mandated. All right, so what I wanted.
So before we go to Larry, so you started out by identifying, what the big problem with XOS people identify, and your kind of solution was to refactor XOS and add microservices kind of architecture. So, so is there? So I didn't understand how far are we in this new architecture, and when would we be done with this? Is it like it's not the current edition?
Yeah, great question. So how long is this going to take? And when I get to the end, I have the priorities. And so just to preview what that says, what we're trying to do for Dangerous Edition is to, it is the theme, stabilize the interface. And that's distinct from the implementation possibly changing underneath. So there will be a protobuf-based representation of the data models that has to make it into Dangerous Edition, because without it, we haven't stabilized the interface. In this next release, the underlying implementation will remain Django. We have the opportunity in the next release to come in and change the Django piece. Now, we have reduced our use of Django down to, it is essentially an object relational database mapping library. But if once you reduce it to that subset of functionality, there are probably alternatives that may perhaps make sense, because Django gives you other stuff.
But if you go back to that other slide when you were showing all the different microservices that make up XOS, so all those, so are these now microservices implemented, and that will be part of the?
So Yang will be done, and Tosca is probably not going to get spun out in its own container. You will still submit Tosca recipes directly to the core. So there will be a subsystem within this container that processes Tosca.
In the Dangerous Edition.
In Dangerous Edition.
And
that
then,
one we definitely want to get out as soon as we can.
And then after that, the next release, so you're saying by next release, all of this will be done. Is that fair?
After shared delusion, this should be, we're never done.
No.
Fine. So there's a couple of unanswered questions, and I'm going to get to those at the end.
Okay.
So let me say that just a little while. There are some risks in the way we're approaching this. There are some forks in the road that we have not yet taken. Let me postpone that one just a little bit, because they are influenced by what I wanted to talk about next. You've seen this picture. It's a nested set of models.
Sorry.
Sorry.
One more question. So it seems there are multiple issues, right? One was the complexity or complexity of writing like the service, but also how slow the system is to deploy or test and so on. So will this new solution solve that problem?
So the refactored XOS, it has to be refactored in the correct way, not to further complicate the build process. So these containers need to be built before they're deployed on the head node. So this is being done consistent with the build process, but it's the refactoring of the build process that's going to address your issue.
All right. I'm puzzled.
So what has been happening is the onboarding process has happened on the head node later than it should. And there were arguments as to why that was, but they're unimportant now. What we decided to do is to do all the build on the development machine before you ever get to the head node. And everything that I gave you on this picture will be consistent with that.
Yeah, that sounds like an improvement, but I guess the thing I'm confused about, which I guess Guru sort of points out as well, it seems the biggest problem with XOS is that it's sort of difficult to use is combined of like kind of hard to use and sort of unreliable, I guess. It seems like.
Well, so be careful about conflating those because a lot of the unreliability is in the build process, not XOS per se. And that's something that we need a better data to split out. But it's not that there was a bug that crashed in the middle of XOS. Most of the time, it's that somewhere in the build stages, I failed to download some OpenStack package. Something timed out and we didn't recover gracefully from that.
So I guess the question is, it seems like changing the architecture can maybe improve the reliability, but it seems that the interface sort of can be independent of the architecture. So are you going to talk about how you're going to change the interface to make it?
Well, so I'm not going to talk about it in any more detail. The key thing is that you give us a set of specs on the data model, and all APIs are generated from that. And there's a very clear model for adding to that API indirectly by loading new models. So and that is the stabilization of the interface. So there's something else that's going on here you have to keep in mind. And that is because we were in this Django, Python-based, let's call it rapid prototyping, not only environment, but mindset, quite frankly. If you did a survey of all the synchronizers, you did a survey of the data models, you would find 18 different ways to do something. And what we're trying to do is distill those down to given our best understanding today, what we think to be the right variant of those. And that's the simplification, ultimately, is that there's not 6 ways to do that, there's 1.
So the data model and the interface are actually different from previously. It's going to be changed.
The representation is different. It used to be the Django specific API. Part of the deal here is that by separating the interface from the implementation, we can change Django out in the future. And we can change out the database that sits behind it. All right, so here's the models. You've seen this slide before. An instance gets combined into a slice. You got a controller, you get a service, you chain a bunch of services together, you get a service graph. I'm not going to go through that in any more detail. What I wanted to talk about, though, is how that drives the back end. And so at onboarding time, I might say I want service A and service B, and this is the dependency between them. And what that means is that runtime, I actually instantiate service instances. And oh, by the way, one of the things that we're going to do is we're going to get rid of the confusing tenant word. Tenant's a principal. Tenant holds a handle on a service instance. We're going to just do a little name change cleanup. Then you'll get back a service instance. And I'm going to spend a fair amount of time on that in just a minute. So again, this is a rough characterization of what happens. And the call sequence is that I want to create an instance of A. The service has been onboarded. I'm at runtime. I want to create an instance of A. I ask XOS to help me. XOS understands there's a dependency and it's going to have to also create an instance of B. And let's just suppose that instance leads to the creation of VM, and we know there's a protocol stack there. We go through OpenStack. Let's just do OpenStack for this example. And there's a sequence of things. This call from here to here is mediated by a synchronizer, by the way. The synchronizer sees the state change and invokes some operation on Nova. Nova does its thing, creates a VM. And the same kind of thing happens for the other VM. But part of the smarts of the data model is to know that the network that connected A to B is going to have to also be created. XOS knows that and invokes all the subsystems to make that happen. Now, keep in mind, this is for the audience that doesn't understand what all the pieces on the inside are. Just to help them understand, there's a stack of things that happen on the inside. And by the way, how did I connect the 2 servers that those VMs ran on? Well, there's a whole other subsystem that does that. XOS asks the fabric to set up. Fabric works on ONOS. ONOS runs in the switches. Tons and tons of interesting and important detail there. But this is just a very high-level description of how people tie together VMs. So this is the kind of thing that happens driven at the root from this data model, where nested inside of that data model, I know there's a network that has this behavior, and VTN sets it up, and so on.
May I ask you a question on
yeah.
this? I like the idea to move the naming from tenants to services, not because it may not reflect the architecture, but there is now the information between the connections between services are contained in the tenant object. Is there a plan to find it in some other way, or?
Yeah, so there's some just cleanup sanity stuff. There's one of the Google Docs in the that's kind of got the last list of name changes and cleanup there. That's one of them. That course tenancy thing was just a bad name.
So this is here. If we run a lightweight CORD agent on each compute node, and XOS can directly RPC to the agent running inside the compute node, we can actually eliminate this Nova layer.
Oh yeah. So when we get rid of this, I'm just doing the OpenStack version of it. And so if you do the container, the synchronizer direction, well, it's actually still using Ansible, but what's called libvirt on the backend machine. And once we go to supporting containers, we could backward compatible support VKVM by doing the same thing.
So just a very lightweight agent running on each compute node, and let the agent instantiate either VM or containers.
Yeah. So this next one is the, oops, I'm sorry, I know everyone says, what about Neutron? Well, it has to be there for backward compatibility reasons. But Neutron isn't running the show VTN is. Because VTN understands how to plumb things together in CORD. Here's the one I wanted to get to.
The nice thing is, following up on him, is you just include you wouldn't need deal with it.
That's right. So here's the service graph. And here is just a rough characterization of the data plane. Obviously trivialized, but this is our coordinates. And I wanted to, this picture is important because it's the distinction between the data plane and the control plane. But remember, the control plane is just the data model. So the point is, as the data model does its thing, it represents the state of the system, and that drives what happens in the back end. And so, if you power your home router up, a packet finds its way into an OLT. And having never seen this home router before in its current instantiation, the packet is forwarded up to the OLT app. All right, so I'm kind of ... is the call graph, hand wave. The point is, I'm now at a point in the data plane that I understand what to do with it. And I'm not going to show the vertical X calls, Y calls, B, but I'm going to show you the interaction in the data plane. And what I'm going to do is I'm going to create an instance, not a tenant, an instance of that service. This is an instance of the Vault service. And I'm going to make sure that it's okay to do that. I'm going to create a subscriber. I'm going to get a subscriber object. And once I return, this is kind of tricky in terms of animation. I've gone up and I've created a subscriber. I've talked to Radius to make sure it's okay. But I have an object in the data model representing the subscriber. I have an object in the data model representing an instance of the Vault service. And Vault says, I got to have a container at the other end of this instance. And so I will call VSG, who will create an instance in the data model. I've not done anything down here in the data plane yet. And that instance needs an IP address, so it goes and asks vRouter for one, and vRouter creates an instance of a service instance on behalf of that subscriber. And as I unwind the call graph, I fill in the links. Okay, I'm simplifying, but this is the data model now knows that there's a subscriber that has this service chain, but that's a chain of instances derived from the graph.
They're just logical. There's no reason they can't have containers, right?
So they're no containers.
At the end of the day, you're just routing.
This is no. This is 18 bytes worth of state data model. Right.
So this is all happening inside the ONOS container, I believe, right?
No, this is the XOS container.
XOS container.
Yeah. This is all within the data model. And
this configuration
effectively, but it's going to be useful for control as well. So what happens asynchronously is all those synchronizers run. And part of the magic of the synchronizer framework is to make sure they all run in the right order. And there's a call, OLT calls ONOS, and some activity happens, and the data path gets filled in a little bit more, and the synchronizer for VSG calls, and I actually had it pre-set up. It sets up the container. I'm now down in the container space, and plumbs through OVS, and vRouter calls through ONOS to get to the fabric, and ultimately plumbs a route for that particular packet to make it out. But again, the important thing was the interaction between the data plane and the data model plane, or the management.
So Larry, I mean, this is, in general, what you're describing is what happens with very a model-based service definition, and then when you instantiate the model-based service services, what happens in data model, and from there you instantiate and configure your data plane.
That's right.
So if somebody from, say, the other day we were at AT&T describing the whole model-based stuff, so their implementation will have something similar as well, in ON.Lab as an example, or eCom.
Yes. So the way, so they will have something similar. How that gets factored between ON.Lab and their controllers might be different.
But they would also have something equivalent of synchronizer that is basically trying to say, hey, you have a data model for this service. Now, in order to connect with the real data plane, you need to have some logic that is going to take that and then instantiate and plumb it together.
And right, you will. And in fact, when we talked to Peter Lee about Yang Forge, he had a very similar paradigm. He had Yang, and he had little actuators hanging off of it.
Mm-hmm. So this is just describing how model-based, I don't know, system or services.
With the twist, which I don't know that everyone does this, that we do this asynchronously, and because our experience based upon past lives was that these dotted edges were not reliable. No matter how much you thought they were reliable, they weren't. And so I need to potentially keep coming back and re-executing until the right thing happens.
Mm-hmm.
And we haven't fully exploited that. We haven't written all the code that makes sure that happens, but it's architected to make that possible.
And again, going back to the problem versus solution, the kind of the meta problem we are talking about, is this, this has been part of XOS from the beginning.
So the main thing that, go ahead.
So
what's different?
What have we done in last couple of releases to make this better in order to address the meta problem we are talking about?
Well, so, and this picture doesn't really highlight it, but the synchronizers are being simplified. Like I said, it was hard for anyone that wasn't an expert to come along and figure out how to write a synchronizer. Hopefully that will be cleaned up. The second thing is, I'm not entirely sure. There's still a question, and I think it's the same one you were asking before, about the granularity of tenancy. And different services are going to attack that problem differently. And we just need to be prepared for that. What else was there in terms of doing better?
Dynamic service training.
But that,
you mentioned dynamic service chain. How does it apply?
I can't dynamically create anything here that wasn't represented up here without onboarding a new service. So if I decide suddenly I need a service I've never had before, I first have to onboard it. And second, there has to be sufficient logic within these services to make the choice as to what to instantiate downstream.
If you wanted to go from the Witcher OLT directly to Witcher router from time to time, you could do that.
You would need an edge from here to here annotated in the appropriate way to cause that to happen. And that's kind of something that CORD wants to do.
I guess so, Larry, maybe I want to ask the question again to see whether so if you are describing the same thing 6 months ago, before all this brainstorming about refactoring XOS and all of that, this description probably would be the same, besides the cleaning up of the synchronizer?
I never called attention to this picture before, because I didn't understand the relevance of it to how we refactored XOS. And the relevance is that the service developer is so focused on this, but operationally, the horizontal cut is also important. And the ultimate tension of how to do this, and I'm not going to claim we have it right, but it's what we're aware of, is how you appropriately balance the vertical and the horizontal. And let me go to the next slide, because what I want to do is talk about the control. Once that path exists, I can now control it. So if you this could be a home user in a self-help portal, or it could be an operator on their behalf. If you wanted to change some parameter of that connection, That is not an operation on a service. It is an operation on the subscriber object. It's the horizontal cut. And by the way, this is an mCORD slice. Same idea. And I'll do a picture in a second. And what happens is I can walk this chain and say, X has changed, X has changed. That's going to be meaningful to somebody. And that's how that information finds its way down. So this is the cross-cutting state that isn't accurately represented by any one vertical. And it's up in the data model, so it's all part of the same global, logically global citrus state.
I've seen this picture like multiple times before, and I've never understood like why it's so like complicated. Why are there all these boxes? Well, it seems to me that all you're doing is you're checking your subscriber database, make sure that they're authenticated somehow, and make sure that they're authorized to use it. And then you're giving them an IP address, and then you're just routing your packets. And so, like,
but I still have to have no. I have to have this state if I wanted to go back and change the parameters of that. This is the state that represents my connection. There's a container. There's some flow rules. There's some OBS rules. It's spread all across the data plane. If you wanted to change one parameter that affected one flow rule, which flow rule would you change? Well, you'd walk this graph. It would affect the state in one of these. The appropriate synchronizer would recognize that state change and do its thing.
Yeah, that's just the opposite of how I would like I wouldn't make any containers at all. I would just sort of delegate connectivity.
These aren't containers. These are rows in a table.
Yeah. Well, okay. How about the things at the bottom, right?
This is a container. This is OBS.
Yeah,
these are just data plane elements. I didn't want to draw them differently.
Okay. I mean, it's a strange way of designing the system. To me, I would like delegate connectivity to somebody like I don't they build an intent for them.
Yeah.
Right. And so like all this would.
But see, as you walk down, this is exactly what happens. It's delegated to vRouter to delegate to ONOS to install the appropriate flow rules. All this is keeping track of is who did this get delegated to on behalf of this particular parameter change.
Okay,
it's bookkeeping.
Okay, yeah, I guess you've just drawn it in a way that confuses me, but yeah, I would just throw away everything at the bottom and have it like essentially talking to either the ONOS house and then.
Yeah. So the dotted lines are the sequence of, like in the earlier slide, it's the sequence of.
And I still don't understand the purpose of BSG. It seems to serve no valuable purpose.
Well, actually, a lot of the implementation of the features that you get for your connection are implemented by the BSG. That's the way the reference implementation wouldn't have to be that way.
Yeah, I mean, once again, I would delegate that stuff down.
I mean, ONOS could have done everything, and then we would be done.
Well, yeah, that's kind of what I kind of think. Except that ONOS is bad at like container management.
Well, yeah. So that's why there's other things.
Yeah.
So this is not the new REST API. This is still the old one, but these are the features that are implemented by different services. And this is that runtime state I was talking about that I remember for a particular connection. Just real quickly, because this is taking longer than I intended, this is an eCORD call graph. And just to point out that one enterprise might come up and get one particular service instance graph across that. You know, I might come in, I just kind of made this up. I got 10 GPON and I got Ethernet as my two connected access devices. And I've got a vRouter and a virtual an L2 VPN going out. This might be what I get, and your enterprise might get something different. And so I get I'm getting one of these service chains, if I want to use that term, which is the instantiation of a service graph on behalf of a particular user. That's different. The mCORD one is more interesting. And this is saying, I don't necessarily differentiate between every single handset that attaches, but this set of handsets all belong to a particular service class. And this set of handsets belong to another service class. And each one of those is a different instance. Again, these are logical instances in the data plane. I'm sorry, the data model plane for these two classes. This is partly to point out that I don't have to create an instance for every single user. Every service decides for itself the granularity of its instances. It could be per subscriber or it could be per subscriber class. And so now the question is, what would have the data plane look like for this? And I'm now projecting into the future because I don't think it works this way, but this is what I would like to work towards. That this instance of subscriber gateway is a slice of instances, and this instance, these are compute instances, by the way, which are the service instance of a compute for service, compute as a service. And this slice, now these are XOS slices, is implementing the other instance of the subscriber gateway. And I just give them different resource allocations. One of them is best effort, and one of them depends on CORD. And that's how I do it. And ... I do the same thing for the other ones as well.
So why do we need multiple instances there?
This is just because I needed to scale up. Maybe one's enough. Heck, maybe one's enough. All right, so I'm coming down to the end here. This interface lets you do these things. Onboard services, synchronize state with the back end, provision the services, instantiate service instances, control those instances. You can learn the inventory. ON.Lab wants that. You can get analytics out of the monitoring service. And so you would take global network automation in from the top. Everything I've just been describing in these examples are part of a local control loop. And then you synchronize with the back-end resources, local resources. And the reason I wanted to draw attention to that is that it's exactly the model that we're going to fit into ON.Lab. And so based upon our discussion, open network activation,
Automation.
Automation, right, automation platform, otherwise known as eComp. eComp meets OpenO, becomes ON.Lab. But in ON.Lab, AIC is the AT&T integrated cloud. There's a set of controllers, and we were just not sure which one of these CORD was, but based upon our discussions at Bedminster last week, we just think of CORD as yet another controller. And in fact, they already have a concept of third-party cloud controllers, or to use this language, infrastructure controllers. CORD is just another one of those. So it's a peer of AIC itself. It's a peer of Amazon. It's a peer of Azure. It's a small cloud. And unlike all those other clouds, it's one that is absolutely unique in that it's optimized or designed for east-west access traffic. And so I don't think I can go to Azure and find OLT devices. And even if I could, well, I can't, but it doesn't matter. I also would not be finding SDN-based services. SDN might be used behind the scenes, but it's not offered as a service. These are the two this picture I really, really like because it puts CORD in a really good perspective that it's just another, at one level it's another cloud, except it's a unique cloud. It's one that has access.
Yeah, I think that's like the most comprehensible description of it that I've ever heard, so I like that. I also like the idea that, I mean, obviously XOS and OS can do network provisioning, which the other clouds will do.
That's part of that, yeah.
Which is a big difference from my perspective, because all these other clouds are really painful if you want to get any sort of reliable or consistent or even kind of comprehensible sort of network services. They may be improving, but historically it's been. That's
right. That's kind of where that's where we're starting. So there's detail here. You would onboard a service into the CORD services into the ON.Lab Design Studio. For ON.Lab, onboarding just says it's now available, like pay the licensing agreement for or whatever. We kind of use onboarding differently to say it's been instantiated. We decide how to clean up the terminology, but once it's been instantiated, then the CORD controller interfaces with it. These are subsystems of ON.Lab. I'm not going to go into the detail, but basically you can provision services, you can learn about inventory, and you can report analytics. And we're going to have to match up those APIs, but what we know about them is that it shouldn't just be a matter of matching up APIs. It shouldn't be a dramatically different thing.
Just to clarify, this project, is that an open source project?
It's open, well, it's a name open source. It's Linux Foundation, contributions from AT&T in the form of what used to be called eComp.
Okay.
And they're merging with OpenO and.
Yeah. Okay.
Okay. End of that. I wanted to come back to the priorities. So this gets back to the discussion we started with. The top priorities to stabilize the interfaces, and then we'll work on the implementation. That's strictly within the space of XOS part of it. Stabilizing the build process, we know what we want to do. As soon as we can accomplish that, then I think it's going to be possible to streamline for different workflows. It's been too complicated to do that streamlining up to this point. It's going to be high priority to integrate a container management service. And once we do that, we can leverage it to build more robust services, because some of them, like Kubernetes, will restart a container for you. And this is a huge challenge. This is my take on the priorities for shared solution. We still have to have that discussion, but aligning the platform and existing set of services, and as Saurav points out completely accurately, that's not just aligning them in the data model, but also the data plane. But they're connected, because it's VTN that's at the intersection of those two. And that's just going to take some effort on everyone's part, but I think it's important going forward. We need to be more comprehensive in the QA testing, and I think there's a strategic discussion we need to have about what's the order of things to do to get the most bang for the buck, but I think we've been incrementally making good progress there. It's just a matter of being more comprehensive eventually. We've now got some clusters at different sites. We've been totally hamstrung by lack of hardware, but we're getting there on that as well. And I think this is the ultimate, forget demos for ONS. What I would like to see demo is our configuration agility, that we can configure a light and write cord without any OpenStack in it, that we can configure both residential and mobile access devices into one common cord, and that we can build specialized cords. And the example that pops out at me is I'd like to do a vRouter cord, which is a configuration of cord that just has vRouter in it, and what vRouter depends on, but it doesn't have anything else.
Atrium?
It's Atrium. It's
okay, just checking.
Yeah. Sure. But this actually is a proof point for us that we have done this right, and that we're not quite.
I get it.
Yeah, we're not quite there. Now you'll notice I didn't say top priorities. I said other priorities, because I can't ever say anything's not a priority. Everything's a priority. But I think I want to do this automation, but I think that can start to happen in the background, and hopefully we come up to speed on that. Operational robustness, we have to get there, but that's a huge. This alone is a huge undertaking. It can't be at the top of our priority list, I don't think. And as much as I would like to improve scale and performance, those are things we're going to have to help working on.
Two thoughts there. One is that PCDK doesn't usually help you with traffic within a
Can you speak up?
Any testing on the OBS? Sorry.
Can you please speak up? We can't hear you.
So you're going to ask a testing question.
Question is, have we done any sort of performance testing with OBS? What kind of throughput we are getting?
We've never done end-to-end testing with CORD. A lot of people have done micro benchmarks on it. So people at the Foundry used essentially namespaces instead of containers to get very high density of subscribers. Long ago, we did some tests that suggested we could do a few thousand subscribers per server.
No, I'm talking about the data path.
That was that was partly the data. That was the data path too, but nothing recently.
So the first two bullets, obviously, you understand, are required for people to take this to
absolutely
trials outside the lab, right? Anything outside the lab, it requires to work with their
absolutely.
So this basically negates that can happen. So some of these
no, these are priorities. They're just other priorities.
Okay. So then
we have to have help with this. And let me get to my risks. Overall, the lofty goals of the CORD have a risk of obfuscating or immediate priorities. And on performance, get it right, then make it fast. On the operational concerns, I'm a little worried that there are some generic things we should absolutely be doing. We should be leveraging anything that improves our reliability. They're just very tough. That's crack. This is I knew that whatever I said here was going to run a risk, but I think part of what we have run into is conflicting priorities on the order in which we get things done. And we'll have that. This meeting is not to set the last word on these. That is the process that happens, least planning. My other risks are this intermodal dependency thing that I chained across. Does this get too complex? I don't know. Possibly you start throwing policies into it. We need to be prepared to back off if that gets too complex. I think there is a cautious way forward that kind of incrementally builds that in. It isn't an all or nothing, but that's a fine line I'm drawing. The multi-tenancy bar may be too high. I think it's the right way to approach this if you wanted a true cloud service, but it's foreign to a lot of VNFs. Again, I think there's half a step back we can take, and I was kind of showing that with CORD, that you still can have very, very lumpy instances. Doesn't have to be per subscriber. And the VTN, this is an absolutely critical piece, and there's a risk that the service composition requirements are just too irregular to try to codify in VTN. We'll see. And the other risk, I think, is platform fragmentation. The service requirements continue at a breakneck pace, and it just continues to outpace what the platform can provide. And everything becomes a one-off, and then pretty soon it's too hard to catch up. It's always going to be they get ahead, we catch up, they get ahead, we catch up kind of thing, but
well, that actually meant a lot about it. Coupled together, and they could be tied to being a victim of your success, right?
Yep. And there's another risk here, which is service dependencies become hardwired. And that's just the nature of building these things. You kind of build, in thinking about just to take vRouter as a cord, vRouter cord as an example. Have we built something into vRouter that was assuming too much about what was upstream from? I'm sure we have. That's just natural because we were slided into a particular graph. We just have to beat those hardwired things out. But that is a risk of fragmentation. It's a kind of funny fragmentation that says you can only put things back together in one way, so you really didn't get the agility you were hoping for. Now, you asked a question that I forget what it was, and if I get back to the answer.
I guess maybe I'll ask him. So if you look at your second slide, I mean, I think that was very well, crisply articulated what our immediate challenges are and what we are wanting to do. And then we somehow got...
we took a detour in the middle.
We took a detour, and it became more an architecture. In general, I love talking about architecture, and that is a lot of fun and good. But if you go to slide number 2,
well, I went back to this slide because the point is you first had to stabilize the interface before you could improve the implementation, for example.
Okay, so that I can understand from the XOS. So yeah, then you're that.
And you
bullet,
have
right?
to stabilize the build process to get the staging right before you can streamline it. So those are.
So okay, so where are we with stabilizing the build process, and what exactly have we done? I thought, I mean, in that second slide, you said, hey, now we understand how to do whatever, configure, fetch, and then design and deploy, or whatever that thing was, right? So, so I think what I'm trying to understand is, okay, I think Refactoring XOS, you provided enough of insight to tell us that, okay, we are now using microservices, we have broken it into microservices, we are in the implementation phase. Yeah, it is not going to be done in the current release, but maybe the next release, the refactoring will be done. It will be microservices based, what the models look like. Okay, great. But as far as the build process, so where are we in?
Okay, good. All right, let's talk about that one. I didn't spend a lot of time on it. The reason I didn't is I think everyone involved in actually doing the work understands what we're trying to do there. There's no big.
So I guess then what I want to know is that when can right. So when can people be able to say they can do CORD build, which is predictable and that is maybe minutes rather than hours?
So I don't have an answer to that. I don't have a hard answer. The soft answer is there's work. There's a lot of work to do. The reason this is say CORD in a box takes as long as it does and fails when it does. And by the way, there's discrepancy into how often it fails. Different people have different experiences. Is a function of 1,000 cuts. And so once we have sufficient data, we know where the next biggest cut is, and we fix it. We know. I'm sorry. No. It's very clear that once you get this right, then you can do a whole bunch of fetching and not so much building. You can start with pre-canned containers. That's going to be huge.
Compelling, like pre-building it and then just shipping the object over rather than having to do a full build on everything.
Yeah, and so you say, why didn't you do that from the start? It's a perfectly reasonable question. And the
answer, I'm perfectly okay not to ask. We are learning, but what I'm trying to say is that I'm still looking for an answer that okay, a month from now, the build process
will be better than it is today.
No, that is not.
I'm sorry. So there's no magic to do this. This is going to take work. All right, and we have not sized it in particular. We know this is a prerequisite for it, and we know it's a high priority.
So I guess if we don't size it, if we don't have a path, then doesn't it become? So what I would like to understand is, yeah, maybe the problem is hard, but if we can either break it down, size it, and say, okay, we need 4 or 5 people committed to do it, and yeah, we don't have it at ON.Lab, then I would go to the community and say, hey, this is a high priority. We want to get this done. Here is a description of what needs to get done. Give me the people so I can make it happen.
I think we have to define first what is that we want, and then definitely.
Well, so I think there's Jono and Mateo would speak up as well, and I don't know who else is online, but I think there's a pretty good understanding of what needs to happen. And the one place that we know we're going to fall short is with OpenStack, and we just have a hard time investing in OpenStack and making it faster because we know we want to get to the containers. So that's all right. So I'm not going to promise it, but the goal is for dangerous addition to, with the exception of OpenStack, have this first bullet done. So what does that leave? That leaves the optimizing it for different scenarios.
Okay.
And step 1 is to identify what those scenarios are. And one of the scenarios, by the way, is in a complete end-to-end build. And I think a lot of people are frustrated by that being the only default available today. So that's really the problem, as much as anything else.
But I guess right now, if I say that if I give you even one default configuration, can I be reasonably sure that the build is repeatable and build is takes a reasonable amount of time as opposed to several hours? So
no,
when you're saying
not if you wanted to build from scratch. That's going to take time. I don't know how much faster we can do a full complete build. The problem we have today is that's the only one effectively that support it. You just don't.
So anytime it fails, then you restart, and you restart, and then you.
That is, if you wanted it. No, you don't. Sorry. Okay. Developers have their own tighter development loops. There's some documented examples on the wiki that you go through the build process. The first time it comes up, it takes 2.5 hours or whatever. And then if you go in here and make this edit, you spin up this container, you iterate tightly, and you make really fast progress. And when you're done with that and you're ready to check it in, you think you're done. But what we want to do is run it back from the beginning again on the full integration test. And that's going to take time. And that's where people are spending time bringing up new CORD, I'm using CORD in the box. CORD in the box experiments is because they now are at the point they want to check their code in, and we want to see that it runs end to end. And the end to end test takes a long time.
So Larry, you're going to say something interesting about.
Mine is the optimization that I don't build everything.
You're going to say something interesting about, like, why you took this approach rather than why you have to refactor now. And I guess Drew said something interesting, sort of indicating like, is it possible to speed up the build process itself? Because it sounds like that might be a bottleneck for developers and people who want to customize their configuration.
Absolutely, and that's exactly what I'm saying. That is what we're going to do here. Now, if I had an ask, my ask would be anyone that thinks they have a really good workflow. Let's use this as the foundation. Let's work on it. And we're going to have a service developer workflow. We're probably going to have an ONOS Synchronization workflow. I want to build an ONOS app and incorporate in the CORD. We're still going to have to bring up OpenStack in certain cases. That workflow is going to be different too. There.
I also like your approach, like OpenStack dependent build. It might help things out a bit.
But it should, absolutely should.
So I guess what I'm saying is that some of these things I would have liked a lot more visibility and a much more concrete plan and what to expect. And so how do we get to that point? I think the refactoring XOS, I'm at least in today's presentation, I got a better idea that what is being done, where we are, and what to expect. But for the other ones, I felt like, at least I'll speak for myself. I don't know
what the target. I can't give you a target time. The very first thing that you work on, and just to call it out because Zach is it's killing him that he can't do this. He wants to optimize this so that he fetches a bunch of containers and doesn't have to rebuild them. It'll probably take him a week. I should throw that out. It's not going to take that tremendous amount of time, I don't think, to optimize that. And it's going to be, you're going to go from 2.5 hours to a lot less. I can't give you a time. I understand that you would like more specificity in what we're going to do here, and all I can tell you right now, this is fun for Dangerous Edition. We still need to have the discussion as to what our priorities are for shared delusion. We will pick I'm going to guess 3 most important workflows, and we're going to try to execute on those. Okay? Now, and one of them, by the way, just to give this one attention, is if you are working on a single service and you want to optimize, so let's call out the single service workflow, single service development workflow. And your service doesn't need OpenStack, but it does need ONOS. It should be possible to bring up a subset of CORD. This is that configurable agility. That is just the services you need. And optimize, that one should be quite optimized. So,
that is already possible.
So have you done it for V router? Okay. We've always had an optimized path for the front end development that you can work on just the data model and the GUI. That comes up in
the first time in 18 minutes when we have to build the XOS-based container, and then for the loops.
Okay, not bad. And what we can, I don't know if this is what you did, but off of that, you could then selectively say, oh, and I also want to do this one service. The thing you have to do is you have to mock. You have to get fake data for the other services. Mock, let's suppose it's VSG. You have to give a mock data model for VULT and a mock data model for vRouter, just because that end-to-end thing is still mocked.
Yeah, as now the easiest way is to bring up all the services without a backend like OpenStack. After their factoring having created good interface between the service, should be way easier to define a mock for the core, so you can technically bring up only your container and iterate on that container, and so it became way faster.
Okay, so we will try to be very clear on what the goals are for a shared delusion. I think that's a great thing to give ourselves the targets for here.
Okay. Yeah, I personally think that it will be very helpful, and
I think there is one point that we have not called out here, but we should work really hard toward that is improve the documentation.
Oh, absolutely.
as now the documentation, especially about XOS, how to build a service chain, how to configure it, is mostly outdated because we have been going so fast-paced.
So one could argue that in bringing up a physical pod, there are problems in configuring the servers and apparently with what interfaces get brought up. And if you step this far outside of the standard configuration wiring diagram, then it's not terribly robust. That's another kind of issue we have to address. And a lot of those problems can actually be solved with documentation. If the second you step off the supported path, then if we document it better, it's kind of on you to figure out how to proceed. It wouldn't necessarily automatically work for you.
So what's your kind of approach to documentation on programs? Just as a, I don't want to digress too much, but it seems that it could be really valuable, especially for you know, because for me personally, it's really useful to help me understand the system, because it's a lot easier to read the documentation or to understand the code after I've read the documentation.
Yeah. So.
Like, what's your approach? Are you doing it? Are somebody hired to do it? Are you expecting the community will magically step forward? Like, how are you going to make documentation happen for coordinators?
Yeah, great. How are we going to make documentation happen is a great question. Most of the documentation right now is done by the people who would otherwise have to answer email on a question. So they're highly motivated to write it down once. And so David Bainbridge documents bringing up the physical pod, and Andy documents bringing up cord in a box. And Scott documents service onboarding. That's the incentive that's there now. And we do need to be more thorough in how we do that. Jono documents vRouter and Fabric and so on.
So just to give you a data point from the outside, I just talked to 3 service providers who I had no previous history with. So I'm assuming they have not been into live, but they brought up CORD multiple times with all the stuff that you're talking about, which was brittle and all of that. So it does work. There is factual proof that it seems to work, and people have done it, and they didn't. Redis and others were helping them.
No, it is working. We did a demo to AT&T, the phase 1, and the phase 2 will be in April. Second week.
Because I saw a rack full of hardware in fact, 4 racks full of hardware at Deutsche Telekom. Yeah. Which is an
I guess the idea not that it's not working.
No, but I mean,
it's working. But the pain point is high, and our job is to bring it
lower. So I'm just saying, don't beat us up too much. But so without the documentation, without all of that, people have made it.
So, for example, for AT&T phase 2 demo, all they need is Volta and ONOS.
Correct.
But because we don't know how to eliminate other services, we are bringing up everything XOS and OpenStack, but we are actually not using XOS and OpenStack.
You didn't have to bring up OpenStack at least.
OpenStack is just sitting there, a bunch of containers not doing anything. So is XOS also.
So anyway, in favor of CORD, we need to say that, well, first of all, without going far, every night at full, or almost full, I would say 90% full, CORD pod is built automatically here every night.
And how often does it see?
Every night.
Yeah, but I think
so there's a lot of, I said 1,000 paper cuts. There's a lot of things going on here. So for example, and this is huge. We just don't have enough data on where things are failing. We have a lot of stories, and I understand that if it failed for you 3 out of 4 times, you go, it's a piece of crap, and you walk away. That's the way it works. But it could have failed because you were building off master and some developer put a bug in. And it could have failed because you had bad network connectivity from your hosting site or from your site. There's 1,000 things that can go wrong.
Yeah, but I guess but that is if there's random people doing it and then they don't data, right? But what I understand is even our nightly build, right? It's not succeeding as often, and so we should know.
And how right? And so we have seen. So talk to different people, you get different answers. I'm not trying to defend the numbers as good enough. I'm just saying that it's all over the map.
Well, but first, there's a big difference between CORD 1.0, right? So first of all, a lot of people talk still about CORD 1.0.
Then we're talking about CORD 2.0.
CORD 2.0 is 2.0, so maintenance branch. That's successful. We can show you the results. That's every night pass. It takes 5 hours, whatever it takes, but it passes. Master for now doesn't. Same experience, honestly, installing lately, right? I didn't want to know anything about core deployment, just to don't be influenced by external people. And I heard lots of things, good or bad, right? And we deployed now 4 or 5 times. The good news is that it doesn't work bad. It's long, right? But it doesn't work bad. So the main problem I found, honestly, I told to Larry, was the installation documentation, which I'm now in the process of rewriting, hopefully by the end of this spring.
So let me look it up as the exemplar of behavior. And we did not plan this ahead of time. But he's been working through it. He's been documenting it, and he's been filing bug reports. And we just have to have that happen.
So my question was to Redis, because they have used
let me share the AT&T.
some of these. No, not AT&T only. I'm just talking about others. Have you documented some of the problems you found?
Oh, okay. But I don't know. I mean, I think, so don't worry. I mean, I think we know many examples of people who bring up CORD and do it. I mean, you saw me 3.5 days non-stop working at MWC selling CORD and how great and wonderful it is, right? So I'm spending all my life. So, but this is the time to take a step back and also understand what the challenges are, because we are hearing those challenges as well, right? And what are we going to do to fix those, right? So it's not meant to say nobody's getting CORD up and working or CORD is not. None of that.
My reason to ask this question is, has Redis has done some work which they have not contributed back to the CORD thing, which people are having better experiences with? That is what the question is.
Right. Sorry. Just because we're discussing also the pains and the good points of CORD, but can I say that is a huge issue for the people I talk to. First of all, to the hardware procurement, especially now that we are doing a demo or in a day, we have to say a quite super safe website. There are things you can order. It would be nice, especially for the hardware for the access equipment. I'm talking about the OLT, ONU, splitter, CPE. So if the things we know, the things we have here are just prototypes, right? If you go out there, there's no right combination of hardware plus software that you can go and buy. So if you buy, example, Celestica, or I just say Celestica because it's the one that I heard more, right? Try to make it work. It doesn't work. I know it's not our problem at some point, but it is on the other because it's the only thing that works with CORD, right? So people have problems with this, even before arriving to the software, I'm saying. So the only thing that is on our website now is a description of the server they should buy, the fabric switch they should buy.
But I think OLT, we should at least include the ones that we work with and we made them to work. I mean,
well, but it doesn't. It's a problem of, first of all, it's a problem of
there are people that know.
Right?
Celestica, there are Celestica boxes that are working. Some of the things that Ashimi is talking about, they have those working with Celestica boxes.
No, that people work with Celestica boxes is one thing. Another thing is that you buy a Celestica box and it works.
Yeah, so that is, so we are trying to get it to the point where it's
So I know that at some point in time that happened, but it's a combination of software of Celestica, Microsemi, Ali patches, other patches. So there's nothing available today commercially.
Okay, are we done?
Yeah, so this is what will be demonstrated to AT&T phase 2. There is no compute node here, only one head node, and that's our ONOS and...
what part of this is CORD 2.0?
It's CORD 2.0. So the head node, we have ONOS and XOS, and this is running, and OpenStack. Okay.
I guess, we are done, right?
Yeah, so the takeaway is We're still doing release planning. We haven't actually officially started it. We've just been brainstorming. So I put up some straw man priorities. We need to hammer on those and figure out where our priorities are. And we also still need to deliver on Dangerous Edition. That is no small task.
And that is what, in 3 weeks or something? When is the?
Well, we're trying to have. It's longer than that, except ONS has this, yeah. Okay.
Well, I just want to thank Larry personally. Again, I think this is really interesting meeting. I learned a lot. I mean, all of you would not for anyone, but it was really good. And everyone for all the really interesting comments. I thought for me personally, it was really interesting.
Thanks. Thank you.
Yep.
All right, we're ending the meeting. Thanks, everyone. Okay. You can take the conference.